So in this video, I want to introduce you to inverse functions. So let's say we had that f of x is x plus 8 over 3, and we want to find the inverse function of f. So first of all, what does that mean? Okay, so I want to return you to function machines again. Okay, so we had the input, and we're going to have two operations. And then we're going to have our output. So what's happening here is that we're putting in an input, and think about the order in which we're doing things here. At some point we're adding 8, some point we're dividing by 3. So remember, we do what's in the bracket first, and there's a sneaky bracket around the x plus 8. So we've got to add 8 first, and then we've got to divide by 3. And that gets us the x plus 8 over 3. Okay? Now, what the inverse function does is it tells us, well, if I start with x as the output, what is the input? Okay, so actually it is that idea of reversing the process, inverting the whole process. So, if I start with x, remember if I'm going this way, I've got to do the inverse of dividing by 3, which is multiplying by 3. So, once I've got through here, I would have 3 times x, so 3x. And then, to get through here, I need to do the inverse of adding 8, which is subtracting 8. So I would get 3x take away 8. And we can just double check that, because if I start with this and I add 8, I'll end up with 3x. And then divide by 3, I get the x. So 3x take away 8 is the inverse function of f. And I can write that, or the expression for it. And we can write that using new notation, where we use this notation, f minus 1 of x. This is the inverse function of f. The inverse function of f. And this would be equal to 3x take away 8. Now, a couple of things here. The first thing is, this does not mean to the power of minus 1. Okay? This means going back on yourself one time, essentially. Okay? So don't get confused with to the power of minus 1, because you're going to think it's meaning find the reciprocal, do 1 over. It doesn't mean that. Okay? So it is notation that is used to mean the inverse function, which is something different to reciprocal. Now, the property of that is that if we now look at a composition, the composite function of f and its inverse. So if I wanted to find f of minus 1 of x, then that means I'm putting the inverse function of f into f. So 3x take away 8 is going into f. So 3x take away 8 replaces the x. Let's get rid of those brackets now. And we've got 3x take away 8 plus 8 over 3. So the minus 8 plus 8 is 0. And so we're left with 3x divided by 3, which is x. Okay, let's do it the other way round. So this time we're going to put f into its inverse function. So f is x plus 8 over 3. And that is going into this. So we'll have 3 lots of x plus 8 over 3 take away 8. Now the 3 times and dividing by 3 cancel each other out. So we get left with x plus 8 take away 8. So those bits cancel, and 8 take away 8 is 0. And so we're left with x. So you're seeing that if you have a composition of functions, of a function and its inverse, you get x. And this is true all of the time. So it turns out that that is x, and that is x. And it doesn't matter which way round you have it. Okay? So, how do you actually find that inverse function without drawing out a function machine? Okay? And going through that process. Well, to really explain why this process is going to work, what I need to do is look at this visually, I think. Now, I'm probably going to go a little bit further than I need to, but I do think it's worthwhile. What we're going to do is we're going to, because we haven't looked at equations of lines yet and like what they look like graphically, but it will be in this algebra section, okay, a little bit later on. So what I want to do is I just want to show you what these things look like. Now, y equals 3x take away 8. Let's draw that one first. I'm just going to get my ruler. So y equals 3x take away 8. Now minus 8 is somewhere down here. It's going to be quite steep as well. So it's going to do something like this. Okay, so this is y equals the inverse function of f. That line there. And then you've got this one over here. So that's crossing through 8/3 on the y-axis, and it's got a gradient of 1/3. So it's quite shallow. Okay, it's quite shallow. Something maybe like this. Okay, so this is y equals f of x. Now the question is, how are these related? Well, they're related together by the fact that they are reflections of one another in this line. Now, I haven't drawn it adequately, really, but this is a mirror line, and this line has the equation y equals x. They're meant to be mirror images of one another in y equals x. And that's essentially why you're seeing this. Okay? So they intersect together on the y equals x line. And that's quite a useful feature to know. Now, if you were to reflect a graph in the y equals x line, then the way to do that is to replace any x with y and any y with x. So if I said you had y equals x plus 8 over 3, if you swap the x for y and the y for x, okay, what you end up with is this. That process reflects, so that reflects in the line y equals x. Now, we don't particularly like it in that form because I've got x equals rather than y equals. So if I multiply it by the 3 and then take 8 from both sides, just going to write it that way round, I get y equals 3x take away 8, which is this. And so this is my inverse function. So the very nature of reflecting in the line y equals x and rearranging allows me to find the inverse function that I need. Okay? So this is kind of like the background of what's going on behind the scenes. In the next video, we'll practice how to find these inverse functions.